Hey guys, how are you all? Welcome to your own channel, Engineering Academy. And in this video, I'll be talking about how to define load combinations in SAP 2000. Alright. Okay, so we have modeled our building. After that, we applied all the necessary loads. Now we are entering into the design section of our tutorial. Alright, so okay, so before going, doing actual design, we have to specify the kind of code we are using and all the load combinations that we're going to be using. Okay, so I'm opening IS 1893 2002 and the clause 6.3.1.2 of IS 1893 2002 says that in the limit state design we have to use these 13 load combinations. Alright, the first load combination is 1.5 DL, that is dead load, plus IL is imposed load or live load. So second load combination is 1.2 times dead load plus imposed load plus minus earthquake load. So you get four load combinations from here. So it's a plus and minus, that's 2, and earthquake in X direction and earthquake in Y direction, that's 2. So 2 times 2, that's 4. So you get 4 load combination from here, 4 load combination from here, and 4 load combination from here. So it's 4 into 3, that's 12, plus 1, that's 13. Alright, okay, so we have to define these 13 load combinations in SAP 2000. So for that, click on design and click on concrete frame design and click on view revise preferences. Okay, so as you can see, it's the design code written here. So we have to specify the code we are using, and so for that, go to click on drop down, and here I'll be using Indian IS 456 2000. So if you see your code here, just click on that code and click here and click OK. So after that, go to define and click on load combinations. Alright, so you can manually add those 13 load combinations from here, or what you can do is that you click on add default design combos and click on concrete frame design and click OK. So as you can see, we got 14 load combinations here. So the first one we don't need it. Alright, so I'll show you second one. Okay, UDCon 2, so that is load combination 2, and click on modify so combo. So here you can see that, so dead load we have added, these are dead loads, parapet wall, partition wall, and these two are live loads. And you can see here scale factor as 1.5, so it's 1.5 dead load plus imposed load. So this is this load combination. Alright, so 1.5 DL plus IL. So we're gonna rename it just like that. So 1.5 DL plus IL. Alright, so you can say LL, that's for the live load. Okay, so it's capital. Alright, so DL plus IL. So this is for later on we're going to use these load combinations, and we have to see which load combination means what. So we have to click OK. So UDCon 3, UDCon 4, it might be confusing. So if we just rename it with the actual load combination name, then it will be easier for us, right? So that is why we have to rename them. Alright, so next one is UDCon 3, and here you can see the scale factor is 1.2, and with EQX we got as plus 1.2. so the load combination is 1.2 DL plus live load plus EQX, right? So that's 1.2. so we have use scale factor 1.2 and all the dead loads plus live load plus earthquake load in X direction. So that's it. Okay, and next we rename as, so it's 1.2 DL plus LL live load plus, so as you can see in the scale factor that EQX has minus scale factor, it means that it's minus EQX. Alright, so that is it. And next one is 1.2 DL plus live load plus EQY. As you can see here, it's EQY, right? And click OK, and you just keep on renaming other load combinations as well. the similar manner. So DL plus live load minus EQY. Alright, and click OK and keep on renaming. So it's 1.5 dead load plus EQX. Click OK and 1.5 dead load minus EQX, right? Alright, click OK again, rename it 1.5 dead load plus QY, right? Again, minus EY. Alright, so click OK again, and so it's 0.9 DL plus EQX. Sorry, 1.5 EQX, is it? Yeah. And .9 DL plus minus, sorry, 1.5 QX. Enter. Again, go to modify 0.9 DL plus Q. So I'm actually using caps lock, so it's a bit confusing, you know. Yeah. And the final one is 0.9 DL minus EQY. Yeah, this is it, and you can see, so it's just 1.5 DL, so we don't need this combination. You can keep it or just delete it. Alright, click on OK. Alright, so now what we do is that just run the analysis. Okay, so let's say 3D here, and you can see start the animation, and just you can see the building dancing. Yeah, that's great. That's for the wall load use. Yeah, that's pretty much interesting, you see. Alright, so okay, so let's go to XG plane and go to display and click on forces and stress frame cables, and come on, shear 2 let's see, and for load combination 1.5 DL plus imposed load, and click on OK. So here you can see the shear force diagram for each and every member, so for this beam and as well as for this column. Alright, so that's the shear force diagram for this structure. And if you go to next frame, you can see the shear force diagram again. Alright, so you know how to see the values as well, right? So click on next. So this is how you see the shear force, right? So if you want to see the movement, then click on frame cable tendons and click on movement M33 and click on OK. So this is the movement diagram for load combination 1.5 DL plus IL, right? So if we change it to 1.2 DL plus live load plus EQX, then you can see the movement diagram changes. Same goes for the shear diagram. So with the change in the load case, the shear diagram also changes. So if we want to see for minus EQX, then in that case, so the movement diagram is something like this. Alright, so as you can see that we got different kind of diagrams with respect to different kind of load combinations. So we can also see for shear diagram. So let's see 1.2 DL plus minus EQA. So the shear diagram is like this for load combinations, and if we change the load combination to EQY, then we see that shear diagram is a bit different, you see, right? So if we change again the load combination to 1.5 DL plus EQX, so you can see we got a different kind of shear diagram, right? Alright, so I want to demonstrate something. Alright, so I have to open this one. So okay, so in this y-axis, let's keep so this is the x, the length axis, and this is the shear force axis. Alright, so this is just an diagrammic representation. It's very rough, I'm sorry for that. I don't have any other equipment to demonstrate this thing. Alright, so first for one load combination, we got shear force diagram something like this. Let's take just an example, right? So for another load combination, we got shear force diagram something like this. Alright, and for yet another load combination, the shear diagram is you see something like this. Alright, so this is just an example. Alright, so I want to demonstrate something. Alright, so these are the highest points of these all diagrams, right? So if we join these points, these high points, we get another shear diagram. Alright, don't we? Yeah, we get another shear diagram. Same goes for the movement diagram as well. So if we join all the peak points and all the highest points, you're gonna get another diagram. Alright, so to get this diagram, we have to define yet another load combination. Alright, so that load combination is known as the envelope load combination. Alright, so envelope load combination basically gives the highest value for all other load combinations. Alright, okay, so for that, go unlock this model and click OK, and go to define and click on load combinations and click on add new combo. Alright, so here load combination type, it must, so let's just rename it to ENVELOPE. Alright, so load combination type, it must be envelope. Do not forget to change it. Alright, otherwise you're gonna get bizarre results. Alright, so after that you have to add all the load combination that you got here. Okay, so 1.5 DL plus EQX, I'm gonna begin from here and click add. So scale factor is 1, and after that DL plus IL, click add, and after that this one. So you can keep adding all the load combinations. So plus EQ Y, after that minus EQ X, plus EQ X, minus EQ Y, minus EQ X. So you add all the load combination. Yeah, we over. Now click on OK. So after that, click on OK. So now again run the model and alright, so you can see how our shear diagram looks like when the load combination is envelope. Alright, click on envelope and click on OK. So this is how it is. Alright, so if you want to see the analysis result for this beam, just right click here and you'll get this diagram. So you can change the load combination from here or load case from there, and you can see what kind of result or what kind of reaction you want to see. And as you can see, resultant shear, so the maximum shear is 43 kilonewton at 3.503 meters. So we are here, so seeing the maximum shear force, and similarly you can see the maximum bending moment, that is 22.96 kilonewton meter at 0 meter. So that is at the support. Alright, so also you can see, if you click on scroll for values, and you just can see, at a particular point, the value of shear force. You can just see, what is the value of shear force at a particular point in the beam. Alright, okay, so similarly you can see that for this beam, and also for this column. So that is resultant shear as well as the resultant moment. Okay. Alright, so this is how you define the load combinations, and see the shear force and bending moment diagram for the members. And but you cannot use the shear force and bending moment values just now, because we haven't yet verified that all members have passed the analysis result. And we'll be talking about how to check whether or not our members have passed the design process in our next video. And okay, so before ending this video, I'll be talking about something. In my previous video, I happened to apply partition load in the staircase as well. So that's not true. So you cannot have a partition at the staircase. One of my friend, in the comments, so he pointed out that mistake in my previous video on application of the load. In order to delete that partition load on the staircase, go to select first and click on select, and click on properties and click on area sections, and after that select slab 125. So we have selected the staircase slab, and go to assign and click on area loads and click on uniform cell, and here select partition and click on delete existing load. Alright, so we have deleted the partition load on the staircase. So alright, so this is it for this video. Hope it was helpful. Thank you.